Okay, Algebra 2. Um, we are going to look at the graph of the rational functions that we've been simplifying and adding and subtracting and solving equations with these rational functions, but I wanted you to get a look at the graph. Okay, so let's start, if you'll get your notes out that I gave you in class. Let's start by just plotting the xy points. Here's our function, y equals 1 over x. And I'm giving you a bunch of x values to use. So in other words, we're putting 1 in for x, for example. So that would be y equals 1 over 1. Well, that would be 1. Then we're going to put 2 in for x. Y equals 1 over 2. That's a half. Then we put 3 in for x. Y equals 1 over 3. Not too tough so far, huh? But they will be not real fun to graph, but we'll get to that in a minute. We'll plot the points in a second. Now I'm going to put a half in for x. So I have 1 over a half. Hopefully you remember that when you divide by a fraction, you're really multiplying by the reciprocal. So that would be 1 times 2 over 1, which would be 2. If if you forgot about that, you would just simply type in 1 divided by a half, making sure you put a half in parentheses so we know we're dividing by a half. And you get 2. Or maybe you decided to write 1 divided by 0.5, because 0.5 is a half. Either way, you get 2. Okay, so 1 divided by a half is 2. Oops, I don't know why I didn't mean that to be yellow. Okay, and then we're going to try 1 divided by, what's next? A fourth. 1 divided by a fourth is the same as 1 times 4, so that's going to be 4. Okay, and again, if you're not sure, if you're like, wait a second, do 1 divided by a fourth. 1 divided by, whoopsies, 1 divided by a fourth is 4. Okay, and then let's put some negative numbers in. Okay, 1 divided by negative 1. 1 divided by negative 1. That's going to be negative 1. 1 divided by negative 2. That's negative a half. 1 divided by negative a half will be 1 times negative 2. 1 divided by negative a fourth will be negative 4. Now what happens when I put 0 in, guys? 1 divided by 0. What's that give me? You're right, undefined. You can't divide by 0. That is our excluded value. Okay, x cannot equal 0. It's excluded from our domain. Okay, the only things we're allowed to use are, well, actually anything except 0. So here's how we show that on a graph. We put a vertical dotted line right where x equals 0. This is where x is 0, right? Okay, there's never going to be a point 0 something. 0, 2, 0, 3, 0, anything. No, I'm not allowed to use 0. So we put what we call a vertical asymptote. X equals 0 is a vertical line right here at 0. We dot it and we say that x equals 0 is a vertical, there we go, sorry, vertical asymptote. Okay. Now let's plot the other points. 1, 1. Okay. 2, a half. 3, a third. Huh? I kind of know what's happening here, right? 4, a fourth. 5, a fifth. 6, a sixth. 7, a seventh. A million, 1 millionth. I'm going to get closer and closer to 0, but I'm never going to touch 0. Okay. Let's see what's happening at a half. When I put a half in, I get 2. So here's x is a half. y is 2. If x is a fourth, y is 4. I'm getting closer and closer to this vertical asymptote, but I'm never going to touch it. Okay? You get something that looks like this, guys. Okay, it gets closer and closer to that asymptote. Y equals 0 is also an asymptote. The bigger x gets, the closer I get to 0, but I never hit it. If I put 1 billion in for x, then I'm going to have 1 over 1 billion. Well, that's pretty darn tiny, but it's not 0 yet. 1/1 billionth is a little bit bigger than 0. Okay, so I'm getting close, but not quite. -1 gives me -1. -2 gives me -1/2. -1/2, that's right here, gives me -2. -1/4 gives me -4. Do you see what's happening on this side? It's the same thing that was happening with the positive numbers, only it's down here in the third quadrant. This is what the graph of y equals 1 over x looks like. We have x equals 0 as a vertical asymptote, and we also have y equals 0 as a horizontal asymptote. There are things that are excluded. Okay, an excluded value is 0. I cannot have x being 0. As a result, I'm never going to have y being equal to 0 either. And you can see what's happening, right? X is getting bigger and bigger and bigger, and y is getting closer and closer to 0, but it never actually hits it. If you try to graph that on your graphing calculator, it will show it to you. Okay, you're welcome to use these. We downloaded them on your laptops the first weeks of school there, so please feel free to use it. If I do y equals 1 divided by x, I just want you to see that the graph looks funny. Okay, like it doesn't actually show you the vertical asymptotes and the horizontal asymptotes. It doesn't dot them in. Okay, and it looks almost like it stops there, doesn't it? Okay, just realize the calculator is trying to show you that it's getting closer and closer. It's trying to show you this graph, but it's rational functions aren't always the most clear things to see on the graphing calculator. All right, it's a little bit nicer to just graph them by hand. Okay, so that's your general y equals 1 over x graph. Let's try y equals 2 over x minus 3. I would like you to pause me right now, put these x values in, okay, use your calculator, put 1 in for x, 2 in for x, 3 in for x, okay, pause me and do it, and then restart me. And by then I will have had I'll have all the right answers here, but please do it on your own first, okay? Pause me and then come back. Okay, so let's look and see if you got the right answers here. Hopefully you got the excluded value is x equals 3. If I try to put 3 in here, 3 minus 3 is 0, and I can't take 2 divided by 0. So 3 was the excluded value, which means right here where x is 3 is going to be a vertical asymptote. Whoops, I didn't draw that very straight, sorry. That's supposed to be right at x equals 3. That's going to be a vertical asymptote showing me that x is never actually going to be 3. Okay, there's going to be a break in the graph here at 3. Okay, that's the excluded value. Then I just stuck numbers in, right? I put 1 in. 1 minus 3 is -2. 2 divided by -2 is -1. So I have 1, -1. I put 2 in. 2 minus 3 is -1. 2 divided by -1 is -2. I tried to put 3 in, didn't work. So I put 3.5 in. 3.5 minus 3 is 1/2. 2 divided by 1/2 is 4. So 3.5 gave me 4. 3.25, that's 3 1/4 minus 3 is 1/4. and 2 divided by 4 is 8. So that's way up here. I put -1 in and got -1/2. I put 2.5 in and got -4. I put 2 2/4 in, or 2 1/4, I'm sorry, in, and got -2 2/3. We're starting to see what's happening here, I hope. 4 2, 5 1. I don't know why I did 0 -2/3. Okay, are you seeing what's happening? Okay, whoops, I'm sorry. The same thing's going to happen with these rational exponents. It's just the asymptotes will be at different places. Okay, but I'm getting closer and closer. Again, I have y equals 0 as an asymptote. I'm never actually going to get to 0. Okay, I'm always going to have 2 over something. So I'm never actually going to get to 0. Okay? Does that make sense? All right. So my vertical asymptote is x equals 3. My horizontal asymptote is still, just like the last one, y equals 0. Those are my two asymptotes. You could graph it on the graphing calculator, and you'll see the same thing. Okay, let's try this one. Y equals -3 over x squared minus 16. I gave you a slew of things to try. Okay, just putting these in for x and seeing what you get. Okay, so do that just like you did the last time. Please pause me so that you actually get a chance to put these in and try to graph it on your own before you look at what I did. Okay, pause me. Okay, these are some not so nice numbers. I realize that. But hopefully you saw that you actually have two excluded values, 4 and -4. Okay, and if I would factor x squared minus 16 into x minus 4x plus 4, it's easy to see that 4 and -4 are what's going to give me 0 in the denominator. Or you just notice it here, 4 squared is 16. 16 minus 16 is 0. Can't have 0 in the denominator. Okay, also, since I'm squaring x, whatever I got for 3, I got for -3 as well. Whatever I got for 5, I got the same thing for -5. So that was kind of good. So let's plot these points. We got 2 1/4. We got 3 3/7, which is a little bit more than that. 4, I got a asymptote. 3.5, I got 0.8. Okay. 4.5, I got -0.7. 5, I got -1/3. 6, I got -0.15. Okay, so that same kind of thing's happening over here. I'm getting close to 0, close to my asymptote. Okay, and if you do the other side, you'll see the same thing happen. Okay, with -5 and -6. Okay, I'm over here at that same type thing, and -4.5. Okay, I don't know if you saw that or not. I hope you did. With the -1, etc., -2, -3, you end up getting almost like a parabola here. Okay, it's a very odd graph, right? When it has two asymptotes, you still have that same type thing happening. Oh, and I didn't put the horizontal asymptote. I still have y equals 0 as a horizontal asymptote. Okay, I'm never going to actually hit 0 as my y coordinate. Okay, so this time we had two excluded values. When you have two excluded values, you have to look kind of to the left of your asymptote, see what's happening in between your asymptotes, and see what's happening on the other side. Of course, I could have graphed this on here. Y equals 3 over x squared minus 16, -3, I'm sorry. And look how it just looks odd, doesn't it? You can't, these rational exponents are tough to see on the graphing calculator. Okay, so you have to use